We have another example on the board. First, we're supposed to find the impedance of the inductor. ZL is equal omega L. Omega is equal 2000 pi radians per second times L, which is equal 160 millihenries. This is equal 1 kilo ohm, an angle of 90 degrees. Please notice that anytime you find the value of the impedance of the inductor or inductive reactance, you're supposed to always add angle 90 degrees if you want to get the answer in the phasor form. But if you want to express this in the rectangular form, you're supposed to write that this is J1 kilo. Next, we're supposed to find Z total. Z total is equal R plus ZL, because this is a series circuit, where R is equal 760 ohms plus ZL 1 kilo ohm, an angle of 90 degrees, where this is equal 1.25 kilo ohms and angle of 52.76 degrees. So this is the total impedance of my circuit. Next, I'm supposed to find I total. I total is equal voltage source over Z total. Please notice that this is the, of course, this is the voltage. This is voltage peak, okay? So dividing voltage peak by Z total, I'm going to find current peak. So this is going to be equal 30 volts over Z total 1.25 kilo ohms, an angle of 52.76 degrees. This is going to give me the value of 24 milliamps, an angle of negative 52.76 degrees. Okay, don't forget that this is peak value of my current. So I can say that I total peak is equal IR peak, and this is also equal I peak. Why? Because this is series circuit. In series circuit, current is the same at every single point. Next, we're supposed to find VR RMS. This time I want you to practice the voltage division law, because most of the time we use Ohm's law. This time we are going to practice a little bit voltage division law. Someone is going to ask why, because we need to review this one more time. So we have voltage source RMS is equal voltage source peak times 0.707. Because I want to use the voltage division law and I'm looking for voltage across resistor RMS, I'm going to convert first voltage source to RMS. So this is equal, voltage source is equal 30 volts times 0.707. This is equal 21.21 volts. So if you want to find V, R, RMS, you're supposed to simply write that this is voltage source, RMS, times R over Z total. So I have 21.21 volts times R, which is equal 760 ohms, over Z total, which is equal 1.25 kilo ohms, and angle of 52.76 degrees. This is equal 12.89 volts and angle of negative 52.76 degrees. This is voltage RMS across the resistor. Next, I'm going to find VL peak, okay, voltage across the inductor peak. VL peak is equal voltage source peak times ZL over Z total. So voltage source peak is given, is equal 30 volts times ZL, which is equal 1 kilo ohm, an angle of 90 degrees, you cannot forget about the angles, over Z total, which is equal 1.25 kilo ohms, an angle of 52.76 degrees. This is equal 24 volts, an angle of 37.24 degrees. This is the voltage peak across the inductor. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of the angle which is next to Z total, 52.76. 52.76 degrees. This is equal 0.605 lag. Okay, so I have lag because the current in the circuit is lagging the voltage source by the angle of 52.76 degrees. That's why we're supposed to write the word lag. Other words, anytime you have positive angle next to Z total, you're supposed to simply write word lag, or lagging, or lags. I used to write lag. Now we are ready to find the true power. P true is equal 1/2 IR peak to the second power times R. We have 1/2 times, we found the peak current, which is 24 milliamps, to the second power times the resistance, which is equal 760 ohms. This is equal 218.88 milliwatts. This is the true power in my circuit. Next, I'm supposed to find the reactive power. QL is equal 1/2 IL peak to the second power times ZL, which is equal 1/2 times 24 milliamps, the second power times ZL, which is equal 1 kilo ohm, and this is equal 288 millivolt ampere reactive. So this is the reactive power in my circuit. Next, I'm supposed to find the apparent power. S is equal 1/2 I total peak to the second power times Z total, which is equal 1/2 24 milliamps to the second power times Z total, which is equal 1.25 kilo ohms, and this is equal 360 millivolt amp. Okay, we found the powers. If you want to draw the power triangle, you're supposed to draw the true power. P equals to 18.88 milliwatts, QL, which is equal to 288 millivolt ampere reactive, and we're supposed to draw apparent power S, which is equal 360 millivolt amp, and this is my angle theta. So we can say that the problem is solved.